This is all well and good if our numbers work out nicely, but what if we don't have numbers that are as pretty as these, that work this easily together? Let's stick with 4 to the x, but how about on the right-hand side of the equation we put something different, like 121. Now, this problem is not as simple as the last two. We can't easily make 121 into a power of 4. So I think we need to go back to our knowledge of properties. In particular, properties of exponents and logs. We have some one-to-one properties. There's this one that we just talked about. If we know that a to the x equals a to the y, then we also know that x equals y. And similarly, we have this second one. If we know that log base a of x is equal to log base a of y, then we also know that x equals y. We also have some inverse properties, properties that demonstrate that exponential and logarithmic functions are each other's inverses. The first one is that a to the power of log base a of x is equal to x. Here's the first one. A to the power of log base a of x equals x. And the second one says that log base a of a to the x is equal to x. This is just showing that logs and exponents undo one another. Now, keeping these in mind, let's go back to that equation we were working with. And here it is again. 4 to the x equals 121. Now, as we did in earlier lessons, I think we should take the log of both sides. After all, we want to extract the x from the exponent here. One of those two inverse properties was this one, that if we have something like a to the x, just as we do here, if we take log base a of that, we'll just end up with x on this side of the equation. That sounds pretty good to me. So thinking about the equation that we have, what base should the log that we apply to both sides be? In other words, what should a here equal?